Welcome to class. Today we shall be discussing matter, changes in matter. Let's unveil the secret rules of matter. First of all, what is matter? You see, for me to define what matter is, you have to know that there are three states of matter. Everything in the universe, everything you see in the universe. When I say universe, I mean whether on earth or in the outer space, everything is made up of matter. Even human being, we are made up of matter. Even the tiniest thing on earth is made up of matter. So these are the three states of matter. Solid, as you can see in this video, represent that with a heavy stone or a stone. It will be a book, anything you can hold and touch, it is solid. Then we have liquid, which is water or anything that flows. Then we have gas, you can say oxygen or other gases. So what is matter? Matter is anything that has mass and occupies space. What does this mean? It means these three states of matter I've mentioned has mass and they take up space. They can occupy space. Wherever you put them, they take up the space. They occupy the space. If you put a stone on a table, it takes up the space. It takes up a particular space on that table. If you pour water in a cup, it takes up the space in the cup. If you fill a gas container, a gas cylinder with a gas, it takes up the space in the cylinder. So all these three states of matter follows this rule of having mass and occupying space. So they are all made of matter. Whether you can hold it, whether you can drink it, whether you can breathe it. If it takes up room and it has mass, it is matter. Do you understand? Now let's proceed. The next thing is the rule of shape and volume. I want you to know that solid has definite shape and definite volume. Let me read what we have beneath this image here. Every piece of matter in the universe plays by these two rules. So let's see how they score. I'm going to show you next. So these two rules are the rule of shape and the rule of volume. When we talk about shape, does that thing has shape? Does that have a shape? If it has a shape, then it is solid. If it has volume and shape, then it is solid. If it only have, let's say it only has a volume but no shape, then it is liquid. If it has no volume and no shape, then it is gas. We are going to see that next now. Yes, this is it. Solid has definite shape, has definite volume. Liquid has no definite shape and has no definite volume. Gas has no, what did I say? You've seen the mistake. Liquid has no definite shape but has definite volume. I'm going to explain it. Gas has no definite shape and no definite volume. So when we are talking about the rule of shape and volume, gas breaks the two rules because it has no definite shape and it has no definite volume. What does definite shape, definite volume means? It means, let's start with solid. Solid has a definite shape, a shape that can be measured. Hmm? It takes its own shape. It has its own shape and it has its own volume. You can measure the volume, height, and breadth. You can measure the volume. So, how about liquid? Liquid has no shape, but it has definite volume. If you pour water on the floor now, there is no shape. It takes no shape. But liquid only takes the shape of a container where it is being put. So if you put water in a cup and you put it in a freezer, by the time the water becomes ice, the ice is going to take the shape of the cup. Do you get it? So it's going to take the exact shape of the cup. So liquid take the shape of the container you put them, since they have no definite shape. But they do have definite volume. Liquids have definite volume. You can measure their volume. Measure their volume. Also, gas. Gas has no definite shape. It has no definite volume. So let's read the note we have here. Solid follow all the rules. Yes. Definite shape. Yes. Definite volume. Yes. Liquid follows the shape of their container, as I've said earlier. So then gas breaks all the rules. Gas breaks all the rules and expands to fill any space. There was a day, no lighter. So I was younger then. I took a lighter and I saw the liquid inside. It looks liquid. So meaning that if you capture gas, it's going to be like liquid. If you hold a gas cylinder now, the cooking gas, and carry the cylinder, you shake it, you are going to feel something like water. It will even be making sound of water. By the time you lose it, you open the this thing, it's going to evaporate. You won't see it. It won't flow out like water. It's going to escape and fill the space. So it's going to escape to the air. So that is it. Gas has no definite shape. It has no definite volume. The next thing we shall be talking about is how adding or removing energy affects the state of matter. Hmm? Matter changes. Matter changes its state if in two ways: if energy is added and if energy is removed. If you remove energy, the state of that matter is going to change. Or if you add energy, the state of that matter is going to change. Let me explain that. Let's take water, for instance. This is water in its liquid state. If you remove energy by cooling the water, the particles, that is, the particles that make up water they are going to pull together. Those particles are going to pull together and stick together. They are going to lock in one place. The water that you put in a jug or a maybe bottle that can shake before will no longer shake, because the particles that make up the water can no longer move freely. Do you get it now? Because you have removed energy. So it forces the matter to slow down, to pull together, and to lock into place. Whereby, if you add energy, let's take that same water for instance, if you add energy to it by heating it, so you add heat energy to water, what does that mean? It pushes the matter to break the rules. So it expands and it moves fast. So if you add heat energy, heat as an energy or a form of energy to water is going to change from the liquid state to the gaseous state. So it changes to steam. So matter changes its state when we add or remove energy. These changes are usually in form of heat. They are in form of heat. So if the heat is being reduced, we put the water in the refrigerator. So since the water is going to change state from liquid to solid. If you increase the energy, that is the heat, what will happen is the water is going to change to steam. So that is the magic that happens. So let's see some processes involved in the change of state of matter. Like we have said earlier, can you tell yourself what are the states of matter? Say it as you are watching me. First. Okay. Second. And what is the third one? Oh, thank you. Now we have gas, liquid, and solid. Solid, liquid, and gas. Liquid, solid, gas. So anyone can come first when you are writing your exam, when you are asked to write it. Okay, let's see. We have here vaporization, we have melting. So if you look at the arrow, look at the bottom, we have ice cubes there. So we target solid. So if solid, look at the arrow, changes to liquid, that is what we call melting. Melting. The question I'm going to ask you now is what can make an ice cube to change to liquid? It is by melting it. Thank you. So how do we melt ice cube to change it to, you say? By applying heat. Yes, it's by applying heat. So melting means solid changing to liquid. So if solid changes to liquid, that is melting. So meaning that the ice melts into water. Now liquid changing to gas, that is vaporization. Liquid changing to gas. I said this earlier when I started this video that if you are boiling water, vaporization is taking place because the heat you apply to the water is causing the water to change to steam. Let me ask you another question. What will happen if you put 2 liters of water in a particular pot and you set fire on it? What happens? If you continue to boil the water, a time will come when there will be no water left in the pot. The question now is, what has happened to the water? Where has the water gone? The very simple answer to it is that the water has evaporated, has changed to steam, and it has escaped from the pot. So it is not the fire that leaked the water, and it is not the pot that swallowed or drank the water. The water has evaporated. So liquid changing to gas is what we call vaporization. So example is water changing to steam or water evaporating. So let's see other ones. Okay, when gas changes to liquid, you can see the arrow there. When gas changes to liquid, that is condensation. And when liquid changes to solid, that is freezing. Let me give you an explanation of how water cycle works. You see, if it rains now, if rain falls, and after it has rained, sunlight comes. Sunlight is heat. So if sunlight comes, that is, it heats up the surface of the earth, thereby causing the water on the surface of the earth to evaporate. So when you are seeing sun, this sun is so scorching, then you should know at that time that evaporation is taking place. Yes, evaporation is taking place. And at that particular time, the water on earth is escaping as gas or as steam or as vapor into the sky, and it is moving up like that. Sorry about this. And it is moving up like that. So what now happens? How does rain forms? It's very simple. That water vapor going up, the higher you go, the cooler it becomes. It does not get hotter. When you go up, it gets cooler and colder. So the water, the steam going up, gets to a point in the sky or in the atmosphere where it cools down. So when it cools down, it hits a surface over there and stops going up. Then it forms cloud. When it has gathered, it forms cloud. That formation of cloud is what we call condensation. So the steam condenses and becomes water. And so when the cloud is heavy, it falls down back as rain. Just like when you open the cover of a pot when you are cooking rice, what happens? The steam that has evaporated from the pot and settled or condensed on the surface of the cover of the pot is going to be dropping as water. So that's how rain forms. And the process continues like that. So that's water cycle. I just borrowed that. So I enjoy that for free. So gas changing to liquid is condensation, and liquid changing to solid is freezing. You can freeze water by putting it in a freezer. So the cold glass mystery. Let me just read it for you. Why does a cold glass of water get wet on the outside on a warm day? You should have asked yourself this question. A cold glass of water gets wet on the outside. Or let's say it is not a glass of water. The one that you are very used to is a all this carbonated drink, maybe Pepsi or Fanta or so like that. Chilled one, cold one, probably the one that is already iced. If you bring it out of the freezer and you put it on a table, what you are going to notice is that the outer body is going to be wet. I used to say in a funny way that the Pepsi is crying, the Fanta is crying. I say that in. But what is actually happening? What is happening is that the because the outside is warm, so there is a process of change of matter that is taking place. So the answer is that the water vapor in the air cools down when it touches the glass and turns back into liquid dew. You get it? So that's the mystery behind the cold glass or anything cold. Okay, let's proceed. Solid changing to gas. That is what we call sublimation. Sublimation is solid changing to gas, changing from solid directly to gas. Imagine ice cube changing to gas like that, straight without going through solid phase. So changing from solid directly to gas is what we call sublimation. Then you can see the arrow. So then the bottom arrow changing from gas to solid. That is what we call deposition. Can you see that? Yes, thank you. Deposition. So deposition is when gas changes directly to solid without going through the liquid phase. Another thing I want to tell you, this explains everything I've been saying since. So melting, you can see the arrow from solid to liquid, freezing from liquid to solid, then vaporization from liquid to gas, condensation from gas to liquid, then sublimation from solid to gas, then deposition from gas to solid. So, lastly, every stone, every drop of water, every breath of air around you is locked in a constant dance of energy. Now hold the map to see exactly how the world works. So matter doesn't disappear, it just changes its outfit. So it can change form, changes from one form to another. So if you enjoyed this video, if you have learned something here, please, depending on the platform you're watching from, subscribe, follow me, like, and comment so that you may see more of these kind of videos. Thank you very much.